My name is Susie. Welcome to this tutorial about Sporcle number grid logic puzzles. So what we have to do in this quiz is we have to put the numbers 1 to 25 in the grid, and there'll be kind of logical clues to do that. So it might say, for instance, prime numbers are only in cells that are even, something like that. So there's some information here to follow, and I'm gonna kind of walk us through the kind of logic of each step. So we've got to put in the numbers 1 to 25 in the correct spots. They each appear once and adjacent. When it says the word adjacent, that means diagonal as well. So 14 is adjacent to all 8, 9, 10, 13, 15, 18, 19, and 20. The whole lot around. And you enter 2-digit numbers as the value, but 1-digit numbers have to be entered as 0, 1. If you are in a different country than England, you might be able to get the tutorial that is in here, but this is not available in England, United Kingdom, so that is what it is. Hopefully we can do it without it. There is some comments to look at if we get stuck. And I've also got an Excel document that I'll be putting these things in. I know my grid's a little bit different. I've got kind of the columns A, so I can have a reference of like C1 would be this, only because it's kind of difficult for me to put in the numbers 1 to 25. It's also a little bit confusing when you've got number 1 and then that might be number 7. But anyway, let's walk through the quiz together and we'll see how we get on. So we've got 20 in the middle square, so I'm going to transfer that to my grid here. Number 20 in the center. And then it says square numbers are in square cells. Okay. So square numbers, oh, didn't want to do that. Do it over there. Square numbers are in, I'm going to put square cells and then I'll sort that out on mine in a minute. One of the 2 diagonals only contain multiples of 4. The other one only contains multiples of 5. So we're talking about this diagonal has to be multiples of 4 or 5. And the same for this diagonal down here. Now 20, you'll notice, is both. So it's not super helpful at this point, but will help us later. That's the only thing we've got. So we're going to pause this one for a minute and we'll come back to that. So, no, I need that actually for a minute because our square cells are, so this one is a square. I'm just going to mark it with an X for now. And then we got number 4, which is going to be this one. Next square number is 9, which is this one. Then we've got 16 there. And 25 is obviously there. So that's our square numbers. That's where the placement of our square numbers. So let's talk about our square numbers. We've got 1, 4, 9, 16, and 25. We know that they're in these. Now, this one and this one are probably the ones to think about the most because this is either going to be a multiple of 4 or 5. So 4 and 16 are both multiples of 4, but 5, there's only 25. So that must mean that this diagonal going down is the multiples of 4. Get down here. 20 obviously works for that as well. So this diagonal must be multiples of 4, and the X spots are going to be 4 and 16 themselves, but we don't know which way around yet would be. But we can mark them in 4 or 16 in there. I'm just going to change the colour of this 20 to represent that it's done. And then this one going down here has got to be the multiples of 5. And this spot then has to be the 25. That's the only multiple of 5 that is a square as well, which means that these last two x's must be the ones that are left over, which are 1 and 9. So kind of mark them in so that we kind of narrow down what we're doing with them. I'm also going to mark on here, we've got 4, 1, 9 and 16 that we've completed, in the sense that we're not going to use those numbers elsewhere. So I just like to mark them as light blue, and also these cells are complete in the sense that they have every number that could possibly go there in there. So if, for instance, we work out this can't be 16, that means it's a 4, because there's no other options that it could be. Whereas this cell, it could be anything at this point. So we kind of don't need this anymore about the square cells, because we've put them all where they go, as close as we can. We've only got the 25 so far, but that'll give us another clue. So we'll pop that in. 25 there. It says one column only contains multiples of 3. So columns go down. So one of these must be only multiples of 3. Now, we've got two numbers in. 20 is not a multiple of 3, and nor is 25. So we can kind of cross off those ones. Can't be those. Now, the 4 and 16 are both also not multiples of 3, so can't be there. And the same there, which actually only leaves us with the 1. So this one must be multiples of 3. Now, it's probably best at this point to write out some multiples of 3, 4 and 5 to help us for later. So we've got 3, 6, 9, 12, 15, 18, 21, 24. That's all the multiples of 3. 4s are 4, 8, 12, 16, 20 and 24. And then multiples of 5 are 5, 10, 15, 20 and 25. Now the 5s only have 5 in, so we could put in these remaining ones as options. So we could have there a 5, a 10 or a 15. The 20 and 25 are obviously already gone, and that completes that box as well. And then we can just copy and paste that to this one and this one. Now this cell has to be also a multiple of 3, so that leaves only 15 to go in that spot there, which means we can remove 15 from that cell and 15 from that cell. Couldn't be a 5 or a 10 there because it's not multiple of 3. And we can change the 15 to a darker colour to show that it is done. And I'm just going to change the 5 and the 10 to that light colour, whoops, to the light one, to show that they're in every spot they can go in. So 5s are kind of done, so again I'll get rid of that. The 4s has more options, so we know that the 20 is essentially gone, so I'm going to get rid of that. And the 16 and the 4 are also essentially gone, which leaves this spot and this spot to be 8, 12 and 24, which we could write in there. That would be fine to write them in there. In fact, I think I will. But we've got to be careful, because that's not to say that 8, 12 and 24 can't go somewhere else, because they could. So I'm going to mark them as light blue on there to say that's all of them. But I'm not going to mark them off here, because 8 could go somewhere else. If this was a 12 and this was a 24, then 8 could go there, for instance. So they're not complete in that sense. But we can again look at this 3s. 8 is not in the 3 times table, so that can go. But 12 and 24 both are. So it still could be that in this, because we've got to remember they're all the 3s. And then again, we could tick off, we could write in all of these numbers in the 3 times table into these spots, but there's quite a lot of options. So I think for now we'll just leave that as it is and kind of come back to that later. But we did get a number, so let's pop that in. 17 is 15 there. The number the number 3 is only adjacent to multiples of 3. Okie doke. So we'll write that here, 3 only adjacent to multiples of 3. So we've got our multiples of 3 there again. And we know that they're going in these spots, but they can go other places too because there's quite a lot of them. But the number 3 itself is only adjacent to 3s, so multiples of 3. So this spot couldn't be it because this 5 and 10 is not in the 3 times table. This 9 could be, if that's where the 9 is, and the 15 is, but this 5 and 10 are not, so that can't be it. Same for this 20, that's not in there. So everything adjacent to the 20 can't be it. So actually let me do that. 25's not as well, so it can't be any of these ones I'm highlighting. Can't be that. 5, whoops, could be that one. Can't be those. 4 and 16 are both not as well, so can't be any of them. Same for there, so it's only leaves these 2 spots for the 3 to go. So I'm going to put a 3 in there, but I'm just going to put a question mark next to it because I don't want it to seem like it's complete. But the 3 is in every spot now that it could be. Get rid of these X's. Just thinking if there's anything else about that. If the 3 was there, oops, that would all have to be in the 3s. That is in the 3s already. That would have to be a 12 or a 24. This one was it. We know that these are already part of the 3s. That could easily be a 9. So I'd only leave one more spot. So let's think about. So this row, column of 3s can't contain this 3 because it's in one of them 2 spots. It's already got the 15 in. Is there anything else it can't be? Okay, so that's quite a lot of options. So we've got 6 options left for 3 spots. Let's assume that this is the 3s. Then we'd have to have 5 spots around it that are in the 3 times table. And then we'd also have to have, so that's 5, 6, 7, 8 in the 3 times table. How many have we got? 3, 6, 9, 12, 15, 18, 21, 24 is 8 spots. So that would be all of the 3 times table. Does that work? 5, 6, 7, 8. I think that could work. No, it doesn't. I'll tell you why. Because 9's in there. 9 has to be in D1 or in D4, which is not included in this 9. So let me just say again. So if the 3 was here, these 6 spots would be taken with the 3s. And then we'd have to have this column also as 3s. 2 of them are already gone, but that's 6, 7, 8. Oh, that's already 9 actually. 9 spots. But in the 3 times table, we've got 3, 6, 9, 12, 15, 18, 21, 24, which is only 8 spots. So this one can't be the 3. This one has to be the 3. So we pop the 3 there. And then we know that this is multiple of 3. We already know this is multiple of 3 because of the column situation. And we also know that this is multiple of 3. Which I believe doesn't leave us with many left. The 3 has to be adjacent to all 3's. So that has to be, which it is, 12 and 24 already are. But 1 and 9, the 1 isn't. So 9 in that spot. Which makes a 1 in that spot. Which means 1 and 9 are done. They can all be ticked off. We will pop those in our grid in a moment. Let's see what's left in this spot. So I think we've got, so that 9's gone. Yeah, so this 3 could be. There's quite a lot of options, but I'm still going to put them in because then that's kind of complete array of what we've got left. Actually too big to see them all, so let's make that smaller. So there's 5 options. That's not too bad. And the same for these 5 options. This one and this one. So that's 4. Yeah. So there's 4 spots. These 4 spots. There have to be multiples of 3, and also this 12 or 24 is going to be also in there. Which means, let me just check that. That's 5. Whoops. 5 down there. 6, 7, 8 is all of the options for 3, which means that can't be. So that becomes an 8 in that spot. Because there's no other option for it, the 12 and the 24 are gone because it can't be a multiple of 3. There's just not enough multiples of 3. And I'm going to get rid of the multiples of 3 over there because we're them all in anyway. And I'm going to change them all to this light blue. That's all the options they could be. Great. We don't really need that multiples of 5 anymore, or the 4, or even the 3. They're redundant, and that is redundant. So we don't have any information to work on now. We've kind of done everything to its completion. So let's put in what we know. We've got a 1 up here. Doesn't tell us anything, that's fine. Then down here we've got an 8. Consecutive numbers are never adjacent. Cool. So that means 1 can't be adjacent to 2, can't be adjacent to 3, etc. So that's good. We'll put in what else we know already. So next to that 15 is a 9. That doesn't give us anything, and 3 also doesn't give us anything. We've got 7 complete, 7 complete. So pause again. Consecutives never adjacent, right? So we want to think about probably the spots that are close to something. So this one down here could be a 5 or a 10, but a 9's there, so that can't be a 10 anymore. It's got to be a 5, which makes this top one a 10. So 5 and 10 are both done. Great. Then is there anything else? We've got 3. Just gonna make that a bit smaller so it actually doesn't look. 3, 4 and a 6, not gonna be close. 5, okay, so that 5 couldn't have 6 next to it. An 8, that's fine. 20 couldn't have a 21 next to it. Adjacent also means diagonal, by the way. So, like this 15 couldn't have a 16 here, for instance. Is there anything else? I think that's all. So we've got a 5 and a 10 out of that, and that could still be relevant later. May well be relevant later, so we'll keep that there. So we got this bottom corner is a 5. No clue for that. And a 10 there. Gives us a clue. All multiples of 7 are adjacent to all other multiples of 7. Okay. Adjacent to all others. So multiples of 7 are 7, 14 and 21. So have we got any of those in here? No. But we can think about, we know that the 21 could be there, there, or there. So let's think if it was there, that looks quite restrictive. That can't have a 7 anywhere around it, or even a 14. So that couldn't be 21 in that spot. There's no way to have anything around it. If the 21 was there, we could have, that could be a 7 for instance, that could be a 14, I think. So I think that would work. That was a 21. Okay, so if that was 21, it's not, but just say it was, we'd have to have a 14 in one of these two spots. If we put it there, it's adjacent to the 15, doesn't work. If instead we put it there, still adjacent to the 15 because diagonals count as adjacent. So 21 can't go in that spot. So we can take 21 out of that spot, which leaves us with, I believe, only one spot to put that in. So I'm just trying to get that. Yeah, 21 is nowhere but there. We've got to have 21 in there. And we've got to have a 7 and a 14 adjacent. Our 7 and 14 aren't in either of these, so that means they have to be in both of these. 7 and a 14. And the only things it can be. Now, the 8 is far away for the 7, and the 6 we haven't got in yet. But, so for instance, if that was a 6, this one couldn't be a 7 because they're adjacent, but we don't know that yet. Now the 14, the 15, where's that? It's down here, so that's not going to affect it. And the 13 we haven't put in yet, but if say 13 was there, then that couldn't be 14, but again we don't know that. So that's fine for now. 14 and a 7. The only spaces they can go, which is why I've put them blue. This is now redundant as well, so we get rid of that. But that did give us something. What did it give us? The 21, I think. There. The value in cell 14, which is this one. Value in cell 14 is not a prime. Now, I underlined all the primes on here. We've got 3, 5, 7, etc. So that's not a prime. So, why does that matter that that's not a prime? Let's think what numbers are left that are not prime. Now I'm going to go through them. If they're black, like dark blued out, they're obviously gone. If they're light blue, this is why I do this. So the 4 is not technically gone, but it can only be in this 2 corner spots. So I can't add it to my list that I'm about to make in this spot because it can't be there anyway. So I'll go through and we'll get, so 2 is prime. Then we've got 6 next. 6 could go there. What's next? Next number is 11, but that's prime. 12 could go there. 13's prime. Next one's 17, that's prime. 18 is left. No. Before I do any of that, I should have already blocked out all the 3 times table because they're all in the spots it can go. So 3, 6, 9, 12, 15, 18, 21, 24. So that was a mistake on my part. I should have blued them out because now it's going to be left with very little that goes in this box. So 2, 11, 13, 17, 19, 23 are all prime, which only leaves the only non-prime left, which is 22. 22 is literally the only number that can go in there. So that's great. 22 in there. So that's in there. The value in a cell never equals the cell's number. Okay. Okay, right. This is a bit tricky because I don't have that. I don't have that, but it goes 1 to 5 here. So it is a little bit confusing because I've used a different method to do it, but this can't be a 1. This can't be a 2, 3, 4, 5. This can't be a 6. That can't be a 7. That can't be an 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So I think that leaves us just with one place for a 6. It does. So remember, a 6 is already complete in every box, can't be in any of these blank boxes. The only place it appears now is this box. So it must be there. That's why it's worth sometimes putting in all the options so you can kind of see quite quick which ones are left over. Right. And then the 6 can't ever be adjacent to a 7, so that must be a 14 instead, which leaves only 7 for that box. 7 and a 14. Yep. Now, just before we move on from this cell number thing, let me just go through one more time, see what else is left. So we've put in the values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Now, so that is not 23. That's the only cell now that's left that either doesn't have the number taken already or the cell number taken already, if that makes sense. So, for instance, that one's empty, but that's cell number 10. The 10's already gone. Or let's think like 2 is not gone, but cell number 2 is not. So that can't be a 23. That's the only information that this gives us now. So that can go. We just know that that's not a 23. We might need that for the future, possibly. So what did we get there? We got 21's next to the 7. No clue there. And then that's 14 down there. No clue again. And that's 4 on the top row. Next to that 3 is a 6. No clue again. And I think that's everything. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so we didn't get any more information, which means we must have information to use that we haven't yet. So there's not many numbers left at all. So it might be worth putting in all the numbers we have so far. So I think I'll do that. So we've only got 1, 2, 3, 4, 5, 6 numbers to fill these boxes. 1, 2, 3, 4, 5, 6, yeah. So let's start with that one because we know that's not a 23. What else do we know about it? It could be a 2. Don't see why not. Could be an 11. Could be a 13. Could be a 17. Could be a 19. I think it could be any of those. Now, I'm thinking, let's go here because we know more about this section. So it can't be a 2 because the 1's adjacent. Can't be an 11 because the 10's adjacent. Could it be a 13? I think it can. 17, I think it can. 19, yes. It can't be a 23 because the 22 is adjacent. So it's actually only 3 numbers, which is not too bad. Oh, just want to be able to see it all. Right. Let's make that a bit smaller. There we go. Right, same here. So 2 can be there because the 1's all the way up there now. 11 works. 13 seems to work. 17 seems to work. 19 works. But 23 doesn't. So that's making me think about this 23 a little bit. I've got a feeling. So all of them are adjacent to this 22. That one we were told was not a 23 because it's in the 23rd spot. So that leaves only this spot for the 23. So yeah, that's our information. But we'll continue with this little process anyway because it'll tell us a few, it will help us later maybe. Just kind of know what's at. So 2 could go there. And 11 could. 13. 17. Not a 19 though, because the 20 is above it. Let's bring that down a bit as well, so we can see everything. And the last one, 2, 11, 13, 17, and 19. I think it could be any of them. So now we've technically done all of them. They could all be blue. It's kind of no point because they're all done. But there we go. That's all we've got. So what did we just put in that was new? This 23 gave us something which is good. Exactly one number is the largest one in both its row and column. Okay, one number is largest in row and column. So let's have a little look at that. Now, I think that must be the 25, right? Because, yeah, 25 is the largest number, so it is going to be the largest in its row and column. But then that makes us think about the 24. So 24 has to share a row or a column with that 25, because if it didn't, then all of the numbers in its row or column would be, say for instance it was there, then all of these numbers and all of these numbers are going to be less than 25 because 25's gone. So 23 maybe or whatever, but couldn't be. So it can't be there, is what it's saying. It could be here because that shares the row and column, and it could be here. So that works. But then we could move on to the 23. Where is the 23? We've done it somewhere. There it is. Okay, that's in the 25 anyway, so that won't be. 22 is also there. 21 is there. Now, 21 will be higher than all of these, because whether that's a 4 or a 16 still, it's bigger. Down here, the options bigger than 21 is only 24, which means 24 has to be in this column. Sorry, not 24 necessarily, but something bigger than 21. Out of the options, the only one that works is 24. So we've got to have 24 in there, which obviously takes it out of there. So 24 is done. I think that's probably as far as we can go with that. 20, sort of 22, 19 isn't done. We might be able to use that later, possibly. There's quite a lot of information kind of hidden in that, but I think probably we've got all we want from it. Right, the number 2 is not in the third column. So look at the third column where you can take out all the number 2's there. Which means it's only left to be in one of these two. And neither is the number 19. Right, so we can take out the number 19 from that spot as well. So again, 19's in one of these 3 spots. Cell 20 is odd. Now, cell 20 is this one. 5, 10, 15, 20, yeah. So we can take out all the even numbers, which is only the number 2. But that leaves only one spot with the number 2, which is that one. So we'll change that there to 2, which is here. Doesn't give us anything, but let's have a look. Let's make that bigger. So we recently got this 2. What else did we recently get? This 24. Right. What else do we know? So 19's only in these 2 spots. If the 19 was here, think about the rows and columns thing. So this row hasn't got anything bigger than 19. This column hasn't either. So 19 can't be there because then it would be the biggest, and there's only one number, which is 25 that does that. Which means 19's only left in this spot. Oops. So 19 must be there. Okay. I don't know if that's going to give us anything or not. There might be more we can do. Doesn't give us anything. We're only 7 numbers away from completing this. 18 situation. Is that the same? No. I think we really have probably done everything we can now with that largest one. We have got this adjacency thing though. So let's think. If that was a 16, That couldn't be 17, but it still leaves two options. So 15. That was a 12. That couldn't be 11 or 13. Ah, okay. Yeah, if that was 12, that would be 7. That would force that to be 17. Then there'd be no options for this because you can't have the adjacent numbers. So instead, that can't be a 12. So it must be an 18. A 12, which makes that actually neither one of those could be 17 for the same reason, the adjacency. Oops. So that's 11 or 13, which leaves that to be a 17. Which means that can't be a 16 again, the adjacency, so it only leaves a 4. 16 up here, because that's the only thing left there. And 11 and 13 don't have any adjacency things, so I think we're going to get one more clue with those. Let's pop in all of that stuff. Start from the top, we got a 16 there, then a 12 below it. That gives us this. The value of cell 18, which is this one, is bigger than the value in this cell. So bigger than a 12. Here, so that must be a 13 and an 11. So now we've got everything, we can just put it in. So in that spot we've got an 18. Oops. This spot we've got an 18. That spot we've got a 13 and 11. And here we've got a 17 and a 4. There we are. So we completed that. Obviously it says that we completed it in 14 minutes, which is not right. It actually took 42 minutes to do it in total. But I hope that makes sense for how to kind of work through each bit. Sometimes better to have things to write down so you can keep a hold of the clues for later if you need them. But yeah, I hope that's a helpful description of how to do things.